called B is equal to numpy dot array 11, 12, 13, 14. Now you can perform one operation. You can perform the matrix related operation simply by calling different matrix related function with the help of an object. So let's say C is equal to A dot add B, and so you can, once you have declared an Numpy array, you can simply perform the numeric operation just by using the addition, subtraction, division, multiplication operation among them. Okay, now let's run this. So you can see the result of addition of both the matrices is, both the arrays is 12, 14, 16. So it's an element by element addition. Okay. Now you can also declare multi-dimensional array. So for example, double dimensional array. Let us declare 1, 2, 3, 4. 1 and 2 in the first row and 3 and 4 in the second row. So if you wish to do such array, all you need to do is A is equal to, let's say, numpy dot array 1, 2. Now this is an array symbol. At the same time, this is a row marker. So if you want to have one more row, put it in a one more array, comma 3, 4, and let's say B is equal to numpy dot array 11, 12, 13, 14, and C is equal to A plus B and print C. Now you can see that this is basically a double dimensional array with first row being 12, 14, second row being 16, 18. Okay. Now so numpy dot length gives the length of an array, okay, or matrix. Let's say I want to print length of A. Now, you can observe one thing, that whenever we are saying that numpy of length of A, it is returning, only length of A, it is returning me 2 instead of 4. That is because it has got two rows. Rows is the first dimension and column is the second dimension. And if you specify print of length of a of 0, there is again 2. So it has got 2 rows and 2 columns. In order to loop through the elements one after the other, you can use a for loop just as you have used it in C. So looping through the array. So how you are going to do? For I in range 0 to length of A. Okay. So for each row we are going to loop for j in range of 0 comma A of I. Okay, so we are going to print the element, print A of I j so if you run this, so 1, 2, 3, 4 we can loop through this element. Now suppose if you want to print it in a matrix format, all you can do is you can take a variable, let's say s is equal to blank string. Okay, say s is equal to blank string. Instead of print, you can say s is equal to s plus str of this element plus a space. Okay, at the end of the for loop, every time the for loop is ended, s is equal to s plus backslash n in order to make it to come to new line. Finally print s. So if you want to format the array as matrix, and if you want to print 1, 2, 3, 4, as you can see this is being printed pretty well. Okay. So what about the matrix multiplication? We have done matrix addition, we have looped through the matrix, printed the matrix. What about the matrix multiplication? Let's see, C is equal to A star B, and let's print C. C is the multiplication result. Let's also print result of multiplication. We can see the result of multiplication showing is 11, 24, 39, 56. Okay, can you multiply, can you take a matrix the result of multiplication should have been different. But the multiplication result that you are seeing over here, this is basically known as the scalar multiplication, where each element is multiplied with corresponding same element. Okay. So observe, 1 is multiplied with 11, 2 is multiplied with 12, 3 is multiplied with 13, 4 is multiplied with 15. This type of multiplication is known as scalar multiplication, and in general, for instance in MATLAB, we use it in this fashion. In MATLAB, we use this scalar multiplication as C is equal to A dot star B. So in scalar multiplication, it's almost like a scalar addition, where each element will be multiplied with the corresponding element, because Numpy, whenever you declare things as array, Numpy treats them as the scalar variables, not as matrices. So in order to perform the matrix multiplication, which is a vector operation, so in order to perform a matrix multiplication, you need to convert this array into a matrix data type. Now see, for a matrix multiplication, all we need to do is we need to convert A and B into matrices. Okay? After you have converted them into matrices, Numpy is going to treat them as the matrix, and it is going to treat multiplication sign as the vector multiplication. It results in 37, 40, 85, 92. If you perform the matrix multiplication, you'll get the same result. So what we understand from this statement is Python treats Numpy treats array operations as scalar and matrix as vector operation. Now, after we have converted A and B into matrix from arrays, what if we use addition in them? What is the change? Now, let us do and see. Say, for instance, E is equal to A plus B. Now note, both A and B are matrices, right? If we print E, will there be any changes? So see, the result of addition, let's put print result of matrix addition, and let's put result of array addition. You can see result of matrix addition is also 12, 14, 16, 18. Result of array addition is also 12, 14, 16, 18. That precisely because addition and subtraction are scalar operation. They don't have a vector operation, okay? Whereas multiplication and divisions are vector operations and they are not scalar operations. So therefore, if you perform a division, so see, let's say result of, let's say, scalar multiplication. Now let's say B is equal to B divided by A, and print result of scalar division. Result of scalar division, print D. Why scalar? Because A and B before this line are still arrays. You see, how is division? 11 divided by 1 is 11. whereas 12 divided by 2 is 6, sorry. 13 divided by 3 and 14 divided by 4. Okay, so you get each element is now divided by each of the element. Now what if we perform the same thing on the matrix? Obviously the operation is just same as your multiplication operation. Row will be precisely because whenever you perform the multiplication, multiplication will also be vector operation. When you perform the division operation, there is nothing called vector division, that is one thing is divided by another thing. Division is also performed on the element of similar length, and therefore this operation, other than multiplication, if you want to perform any other operation, those operations can be performed on the arrays. Now, in which situations you should take arrays, in which situation you should convert them into matrices. Now, many matrix specific operation will be there where you may need to have a transpose, or you may need to take an eigenvector or calculate principal component analysis of a matrix. In all such in all such scenarios we should consider it as a matrix. However, do remember that because matrix is overloaded and has many functions, the operations on matrices are far more slower in comparison to whichever operation you perform on the arrays. So if your data is pretty simple, you can take arrays, and if your data requires specific matrix operation, you can go with what you call matrix manipulation. Now, there are several other matrix operations. So for example, if you want to perform a transpose in the matrix, let's say that I want to take a transpose of A. A is 1, 2, 3, 4. So 1, 3 is the first column, which will become first row. As you can see, 1 and 3. It was 1, 2, 3, 4. 1 and 3 was first column, which has become first row. And 2 and 4 was second column, which has become second row. Okay? Now, three, 4 followed by 11, 12, 13, 14, and the length of C0, that is each row is now having 4 elements each. Okay, so each row is having 4 columns. On the other hand, if you make axis equal to 0, it is going to be row wise concatenation, which means after one matrix is completed, the another one will be put below it. So 1, 2, 3, 4, 11, 12, 13, 14. Now see, every time I am having to write numpy.concatenate, numpy.matrix, so and so. Python also gives us a facility to import any library with a short form. Say import numpy as, let's say, np. Okay? We can give a short name. Now, having done so, we can easily write once you have taken a short form, Instead of writing Numpy, you can replace it with NP. There are many libraries which are quite big in name, so all you can do is give them a short name while importing the libraries, and finally okay. So which means that in Python, if you are importing any library as it is, say import Numpy, with the library name you can access the function. Else you can give it a short name, you can import it with a short name, and you can access all the functionalities with a short name. Numpy is not defined. Anywhere it is left out here.